All right, good morning, everybody. Welcome to reInvent. Glad you guys could come out this morning and join us. This is going to be soup to nuts, identity federation for AWS. My name is Quentin Van Diemen. I'm the Business Development Manager for Identity and Directory Services here at AWS, and your kind of unofficial tour guide for the day. So what to expect, right? So identity federation means a lot of things to a lot of different people. So we're going to first, before we dive deep into the details of what it means at AWS, we're going to just make sure we level set across the room, make sure we have a consistent vernacular and kind of what we like to call at Amazon a mental model around how we think about identity federation. Then I'm going to take you across what I call a tour of the major federation bridges around AWS. We'll get into why as we go through the talk today, but there are a number of different mechanisms for federating identities into AWS, and we're going to go through kind of a whirlwind tour of all of them. Along the way, I'm going to give you hopefully a fun and lively session with lots of good demos and links to go away from. At some point, it is a challenging session to try to make identity federation demos compelling and interesting, but we're going to do our best, and it gives me a little bit of risk of failure up here just to make it a little bit more exciting for me. But that won't happen. Knock on wood, somebody. And lastly, I'm going to give you a lot of links to content and patterns to take away from here. I've tried to even go one level beyond the token embedding the links. Got a lot of QR codes and other things, so if you're fans of snapping pictures of slides, hopefully we can get your good deep links right to the information you'll need. So let's jump in. So first, what do we mean when we say federation? Right? And I'm not going to get overly hung up on a textbook definition of what it might mean or what it might mean in some of the circles within the kind of the federation spectrum of the world. We're going to define our own definition for today. On one hand of the equation, we're going to have our identity providers, right? And these are the systems, and it's normally comprised of both a directory and a piece of software that's going to speak a federation protocol. And that's where we're going to store our identities. This side of the equation is fully responsible for authenticating our users through whatever factors they might use, and providing generally a coarse-grained level of authorization or entitlement into what that user is authorized for. On the other hand of the equation, we've got, we'll just call it generically, an identity consumer. On this side of the fence, we're not going to actually store the credential, we're not going to store the identity, but we're likely going to store a reference to that. We still have to have a notion of who that user is, but we're just going to do it in a level that's once removed from that actual super sensitive credential through a non-sensitive link. This side of the equation is where we're generally going to do fine-grained authorization. So authorizations that are a level deeper than the identity provider really would have reason or ability to impart. Think of these as in-application type of authorizations. These two are going to get together and they're going to establish a trust ahead of time. And this trust is going to come in a couple of different forms depending on the type of federation we're talking about. We'll go into that in a bit. They're going to rely on standard-based protocols to interoperate, right? This world of identity federation wouldn't work if we didn't have standards out there. And lastly, at least in our definition for today, we're going to look at federation as being involving a situation where those two parties do not need to sync or replicate any data between them. Okay, so now let's go through, if that's a reasonable definition for federation, let's go through why we might go about this effort. And I like to usually talk about this in terms of three basic constituencies within your organization. The first are your users, right? And I think that the moral of the story is pretty obvious here. In a world without federation, they've got unique credentials everywhere. We all know that pain. It's 2017. We don't need to berate it anymore. With federation, they get one-to-many reuse. The next is the security department, right? Especially in this day and age. Without federation, we've got kind of credential sprawl. We've got multiple castles to protect. And with federation, we get those credentials centrally managed, kind of one place to defend. And lastly is the compliance department, right? And I figure at this day and age, most of you in your organizations have figured out identity management in your own organizations. But if we don't you bridge in that mechanism into the federated world, we get these bespoke pockets of identity management where you've got to do that onboarding and offboarding kind of pain all over the place. But if we bring identity federation to bear, we get unification of that, and we can just leverage the investments you've already made. So as in our last point of introduction, maybe switching gears a little bit, I want to talk about what I call planes of access, right? And this will become, the reason why we're going to go through this will become evident as we go through it. So let's take a service like Amazon EC2. We've got one plane of access that most people would call the control plane, right? This is an AWS API where you're going to do things like start, stop, run, reboot. You're going to do kind of the control operations around that service. That is wholly different from the data plane, a connection that's going to come in through the VPC layer of your environment, where you might make an actual connection to that running operating system using SSH or RDP, depending on the OS. And that's important because those two different planes of access have different paths, they have different credentials, and they have different protocols, right? And so keep that in your mind as we go through the talk today. Now we compare that to a different AWS service like DynamoDB. And here we've got that same control plane that's also an AWS API, DynamoDB create destroy table, for example. But that is unified in this case with the data plane API. The way you put or get items out of DynamoDB is also an AWS API, right? So here we've got, we've got the same path, credential, and protocol for the service in both the control plane and the data plane. So just keep those planes of access in mind as we go through this. All right, so now let's talk about this mental model, right? And the mental model is, again, kind of an Amazonian thing that we like to do just to kind of visually orient our thoughts around a particular topic. And I'm going to give you this one, and we'll circle back to it in the end, but it's just, again, kind of a reference to try to orient your thoughts around the topic of identity federation. So in this mental model, we're going to first start with our use cases. We're going to start with what are we trying to solve identity federation for? Is that AWS itself? Is it a B2C app? Is it a consumer service? So let's start with the use case first. Let's go through our evaluation that's going to include the three items we just talked about. So path, protocol, source credential, those planes of access. Make sure we've got that straight. That's generally going to lead us to one of the established federation bridges within AWS that we'll go through here today. And ultimately, that should lead you to a set of established blueprints. Any of these things that I'm going to show you today have been well-trodden paths that you can rely upon and hopefully draw upon these patterns that we're going to show you. No need to reinvent the wheel. All right, so let's dive in. The first bridge we're going to look at today is SAML, Security Assertion Markup Language. And right, this was probably the most people would consider the origin of this this federated identity world. And as a quick SAML primer, in SAML parlance, the part on the left is called the identity provider, or most people would just call it the IDP. We've got then the service provider on the right. That's our identity consumer in this case. Those two are going to get it together, and in advance, they're going to exchange some metadata. This is an XML document that defines all sorts of certificates and attributes and things that form the cryptographic basis for that trust that we talked about earlier in the SAML world. After that trust is established, at runtime, all the authentication and the coarse grain authorization for the user goes against that identity provider. And when satisfied, the identity provider is going to send what's known as a SAML assertion at runtime back to the service provider. And again, this is coming together ahead of time, forming a cryptographic trust, so that the service provider on the right knows that it can trust the identities coming from the provider on the left. So now, where do we use SAML federation within AWS? So mostly we're going to be talking about our internal users, the users inside your own organization. They are going to already have likely credentials in a backend directory, Active Directory, OpenLDAP, whatever your particular persuasion is. That is going to be joined up with a SAML IDP. This is the component, again, that's speaking that protocol layer. And we're going to build that SAML bridge into your AWS world. The first and most notable use case for SAML is federation into AWS itself, that control plane, whether that's the console, whether it's API access, whether it's CLI access, etc. As kind of a natural extension of that, we also get through that same bridge federated access into those data plane APIs, right? DynamoDB, S3, SNS, anything that speaks its data plane over an AWS API. We're going to add on to that, and we're actually going to go all the way up to the other end of the stack. And we're going to look at how SAML is a great tool to bridge your federated identities into for end-user-facing applications. And in this case, because we're talking about SAML, we're probably talking more about, again, those internal users. But we'll see how Cognito can bring in and can join those federated identities into Cognito-enabled applications, and then has some really neat tools for being able to extend those identities all the way through API layers that you might build in something like API Gateway. But let's look at some of that might look in actual demo form. Spent all that time making sure my stuff was ready to go, and it timed out at the last minute. All right, so here we go. We're in the AWS console, and the first thing we're going to walk through today is federation inbound to AWS. Again, Management Console, CLI, API type usage. So to do that, I'm here in the IAM console. I need to do two distinct things. First is I need to create an identity provider. I'm going to go ahead and choose SAML. I'm going to give it a reasonably descriptive name. I like to use Shibboleth because I'm an open source fan at heart. And I'm going to choose a metadata document that I pulled down from my IDP. And again, this is that document ahead of time that's going to convey information about certificates and attributes, etc. I go ahead and create that. And now I've essentially given AWS a method to say, I trust identities that come through this identity provider. The second thing we're going to go ahead and create are a number of IAM roles, right? An IAM role, if you're not familiar with it, is an AWS identity primitive. It's kind of a jack of all trades, or a Swiss Army knife, right? It does a lot of things. You can see there's lots of different ways that we can establish trust with a role. I'm going to choose SAML Federation. I'm going to select the provider I just chose or just created. I'm going to designate that I want this to be both for programmatic and console access. I'm going to move on to permissions. So I'm going to use one of these managed policies. See if we can select one for read only. There we go, read only access. Review, give it a reasonable name. 3, read only. All right, and create. And just to make things a little bit more interesting when we get into the user side of things, let's go ahead and we're going to create a second one. Go a little bit faster this time. Same identity provider. Programmatic access. Permissions. Go power user. View, Shibboleth 3, power user. So essentially what I've done here is I've created two different roles with, if it wasn't obvious, different sets of permissions, right? And so those permissions I attached with those fine-grained authorizations. In this case, the identity provider is going to be responsible for what roles I can assume, but the roles themselves are going to define what AWS actions and resources I can access once I come across the federation bridge. So at this point, my job within the AWS world is done. I've got my roles, I've got my identity provider configuration. So now I'm going to switch over and I'm going to do the kind of the back end of things. I'm going to do the identity provider side. So the first thing we need to do is populate a number of, we'd have to create our user and group accounts in our backend directory. I trust that you all probably wouldn't be super enamored with a demo of creating users and groups, so I've done that kind of already here for the sake of time. What I draw your attention to, and this is the user I'm going to be using, is that I've placed that user into two groups that have a fairly specific naming convention, right? And this is something we patternized over time, but we're going to use the convention AWS-account number-role name, right? And so that's going to make it so that these groups become the system of record for what this user, which accounts and which roles this user is able to federate into. With the directory side at hand, the next thing I need to flip over and look at is the identity provider side, right? So I'm going to use Shibboleth here, but this pattern or these configurations are generic, whether you were talking about Okta, OneLogin, Ping, ADFS, any identity provider applies. So the first thing I need to do is pull down the corresponding metadata document, just like I did in reverse, but we're going to kind of flash forward over that, and we're going to look at what's arguably more interesting, the attribute definitions that we need to use within the identity provider. So there's 3 specific attributes you need to configure in this case. One is just name ID, whether it's persistent or transient. It's a fairly standard federation mechanism. The first real AWS-specific attribute, and I made this probably as readable as XML could get on a big screen, so I apologize if it's not awesome, but is the AWS role session name, right? And here, this is really important because this is going to be your traceability for your users through CloudTrail for all their actions when coming in as a federated user. You want to set this to something like UID, email, something that's highly traceable back to the user. But the more interesting one of the two is the AWS roles attribute. And again, this is going to be what AWS is going to use as the assertion coming from your identity provider about what accounts and what roles attested to by what identity providers AWS will allow the user to go into. And what we've, again, kind of developed over time is you certainly could set that attribute on a per user basis or through any number of different other mechanisms. But we've generally advocated that you go with a regular expression based, right? So we can take that regular expression, which is AWS dash 12-digit account number dash word for role name. And using something like this, I've essentially, with those 2 pieces of information, got everything I need to do or need to create both the ARN of the role and the ARN of the identity provider. And what's really powerful about this is if you can implement a pattern like this, essentially it's a set it once and forget it type of approach for your IDP. You can add any number of accounts, any number of roles, and you'll still have to create the corresponding groups in the directory, but you'll never have to touch the IDP again. So let's look at how this might actually look from the end user's perspective. So we'll start from a new incognito window. We're going to hit my identity provider login using the initiated login URL. Logo aside, this is not AWS. This is Shibboleth running in EC2, and I'm going to log in with my corporate credentials. What goes on in the background here is that identity provider is going to inspect those group memberships, going to funnel them through that regular expression that I just showed you, and here is my entry point into AWS. This is what's known as the role chooser page, and here the user is going to designate the account and the role they're interested in operating in, and they make that selection and they drop into the console as you'd normally expect. They then go about their business. They're bound here by the permissions that were associated with that role. And if they want to switch context, whether that's going to a different account, a different role, they hit that IDP-initiated login URL again. The magic of single sign-on works, and I simply just select the other role that I want to go into. And that would work across accounts, across roles, et cetera. So that's kind of how the management console works. The story within on the command line side is basically the same. It does these days, or it does still require kind of a helper script, if you will, that runs client side. But those have been out there in some blog posts for a while. So I'm going to run one, and it's going to just prompt me for my same enterprise credentials again. And probably going to spit out a little bit of innocuous air, but essentially beyond that, it gives me a choice to choose one of those same 2 roles that I was entitled for before. I'm going to go ahead and make my selection. And what it's going to do in the background is fetch an STS token, stash that in my credentials file. And now with the simple addition of this -- profile SAML that I'll show you here. If I just, with this -- profile SAML, I'm able to execute any command without ever having a source credential or without a long-term access key, secret key pair, if you're familiar with those, and execute any CLI or API code that I might have. So that's kind of identity federation inbound to AWS at that control plane layer. So now let's quickly flip over and again, kind of switch context to the top of the stack. Now let's say we've got an end user application, and I'm going to get a clean browser just to make sure we get a clean session. And so we're going to now look at how we bring federated identities into an end user facing app, right? In this case, one that's servicing our internal users. This is a Cognito sample that's a single-page application running out of S3 with CloudFront in front of it for TLS purposes. And right now, I've just got basically the stock application, just like you'd find in the Cognito documentation. And it's essentially configured for Cognito user pool authentication. So I could log in there with a username and password out of my user pool, and totally not federated identity. So let's add the notion of federated identity to this app. So I'm going to go over now to the Cognito service. I'm going to manage my user pools. I will point out that it is a bit confusing that the older mechanism for federating identities in Cognito was distinct. These days, it is actually within the user pool itself. So we're going to flip over there. We're going to go into this user pool that I've already configured. And the first thing we need to do is, admittedly, a bit duplicative, but we actually got to go in and we've got to establish that same SAML identity provider. Right? So I'm going to browse that same file, give it the 3, I'm going to create the provider. Okay, so now now I've kind of done the same basic step of making sure Cognito knows that it can trust my identity provider. The last thing I need to do, kind of on the identity provider configuration side, so I want to map some interesting SAML attributes so I can use them in my Cognito app. So I'm going to create myself a little cheat sheet here. So I'm going to take this role session name that we talked about before, and I'm going to map that to preferred username. There it is. And then I'm going to take a second SAML attribute for this cryptic OID notation for email and drop that into email. So what that's allowing me to do is essentially take attributes that my identity provider asserts about my user and use them within my application. So now that I've got that in place, I'm going to go to the application that I've already configured, that single page app, and I'm simply just going to select that I want to enable my identity provider. I'm going to save those changes. So if we come back to our single page application, let's get okay, I got too fancy with the clean browser there and closed them all. All right. There we go. So we're going to come back. Same single page application. Now when we sign in, now if the demo guides are with me, we do not need that, sorry. We've now got 2 different sign-in options available to us. We could sign in with the user pool that we had before, or we've got also the Shibboleth 3. If I go ahead and sign in there, again, sign-in demos are always super exciting, but we'll do it anyways. And we've now managed to bring our federated identity into this application. Now, that's interesting, but I think, so what Cognito does in the background there is after that SAML identity comes in, it normalizes it into a user pool identity, which means in the background it's essentially issued a set of Cognito tokens that are their standard OIDC access, or identity access tokens, right? And what that enables us to do is I've wired together an API that I built with a Python serverless framework called Chalice. If anybody out there is interested in getting into the API gateway world, but hasn't had a chance to really dive deep into it, I'd highly recommend it. But what I can do is I can use the tokens from Cognito that it gave me back after my user federated, and I can use those to actually invoke an API that's protected with that Cognito user pool. This API that I wrote was simply a who am I type function. It just parroted back the user's identity. And what you can see here is I've been able to actually draw in the preferred username out of the SAML assertion, drive it through Cognito, drive it down all the way, and have a notion of the user's identity all the way down in the API executing in the back end. And so I've been able to carry the user's identity all the way through the farthest reaches of my application. And I think that's a really powerful concept. We're not going to dive super deep into it, but just so you can get kind of a sense of what Chalice is all about, this is essentially the extent of that API that I just showed you executing in the background. All I really needed to do was define one function that is ultimately going to be compiled and uploaded into Lambda. And in this case, I just returned, again, the contents of the authorizer, right? So what Cognito handed down to API Gateway. And that gets mashed up with a user pool authorizer in a kind of a one-line configuration, and that's about it. And so I can just configure a simple Python file like that, define the functions, define how I want those APIs authorized, in this case through the Cognito user pool, upload it through Chalice, and it'll do all the hard work of building the Lambda functions, building API gateway definitions, all that sort of thing. So if you haven't had a chance to check it out, by all means, look up Chalice. Super powerful framework. Okay. So let's switch back here. Okay, quick recap, and I know that was fast, right? I am going to hang out here afterwards as long as anybody wants, if you want to go deeper, you still have questions. So in the first demo, we kind of saw all about how to do SAML federation for AWS itself. Last year here at reInvent, we did a self-paced workshop that's still out there on the wide world of the internet that's got everything you saw and much, much more and much greater depth. And then secondly, we looked at how we brought the same SAML federated identities up to the front door of our environment and used a single page application through Cognito, used Cognito as kind of a normalizing layer that translated the SAML federated identity into a Cognito set of tokens, and then used those tokens to call an API in the back end that was implemented using Chalice through API Gateway. Okay, so now that's not necessarily the entire game or the entire story with SAML federation. We can do some other neat tricks as well. Probably the first one that I'd bring to your attention is these days a number of the relational database services within AWS, notably Redshift, Aurora, and RDS MySQL, can actually do IAM-based authorization as a distinct method other than kind of the user name and password database engine types of authentication that they originally had. And you can use these same federated identities over that bridge into the role to establish connectivity into those databases. You've also got kind of end user facing type applications. The first two that have come out through AWS are QuickSight and AppStream, but you're able to bridge in federated identities into those platforms as well. And then last but not least, certainly the benefit of standing something like this up in your environment, if you don't have it already, is a lot of the world of SaaS and just internet software in general has really used SAML as kind of a standard for federating all sorts of SaaS apps. Okay, so now let's quickly move on. And our next bridge that we're going to talk about is OpenID Connect. OpenID Connect, something of a successor to SAML, tried to make some of the things that were painful with SAML a little bit more standardized, a little bit more straightforward. But in OpenID Connect parlance, we've got the OpenID provider on the left-hand side, serves the same role as before. On the right-hand side, we've got what's known as the relying party in OIDC speak. Same as before, these two get together ahead of time. There is a metadata document here as well, but it doesn't serve the same purpose. This is where we actually, the OP is providing description about where its endpoints are and things of that nature. There is a registration process where you'll go and you'll register your app with the OpenID Connect provider and get back a client ID and client secret. And we'll see that in a bit. So that's kind of establishing the trust for OpenID Connect. Same as before, all the authentication and authorization is going to happen by way of the OP. And then in this case, instead of an assertion, we're going to hand back a set of tokens. In OpenID Connect, there are 3 distinct tokens. There's an ID token. As the name implies, this is the user's identity. There's an access token, which the user can use from within their environment to call out to APIs. And there's a refresh token that just allows them to acquire a new access token when one expires. So where does OpenID Connect fit within AWS today? For the main use case that you're going to see here is about bringing in external users, right? And by external, I just mean anyone that's not necessarily strictly an employee of your organization. They are most often going to come through one of the established OpenID Connect providers out there on the internet. Google, Facebook, Twitter, log on with Amazon is the one I'm going to use today for demonstration purposes. But we're going to create that trust as we did before, this time in the form of those client ID and secret registrations. And we're going to establish trust using OpenID Connect. And the first thing we're going to enable is we're going to bring those types of social identities into that same Cognito layers we saw before, right? And we'll see the same kind of normalizing function that Cognito serves in that capacity. Cognito has some really neat tricks that you can actually do without Cognito as well, but Cognito makes it really easy. Essentially, once we've got the user authenticated and authorized through our identity federation, we can translate those OpenID credentials into AWS type credentials that could be used within a client app or a server-side app to actually do other AWS API calls, most notably into the data plane, right? And so this is where we federate in the user, but then carry the notion of the user's identity to see what files they might be able to pull from S3, for example. It's perhaps not as prevalent today, but growing in commonality where we might have an OpenID provider in the corporate world as well. And in this case, we establish the exact same federation bridge where we're able to draw those internal users into the same mechanism. Certainly possible today. It's going to most notably enable that Cognito and the data plane use case. But it's certainly possible. And then the last one that I think is really interesting to consider for OpenID Connect is the notion of how we might use or how we might find a common language that an application on-prem can talk to an API within AWS or vice versa. Right? So if you were in AWS wholly, you would probably use IAM roles for EC2 or Lambda to just have it be a purely AWS credential type of equation. But when you've got one side of the mechanism on inside versus outside, OpenID Connect is a great bridge to allow you to do that. And we'll see that in a second. Okay, so let's again go into some demonstrations here. Okay, so the first thing I want to do is I want to go back to that same Cognito single page application, and I'm going to enable log on with Amazon, so AWS or Amazon's social identity provider to bring in social identities. So I've kind of already taken care of a little bit of this in advance, but I've got here is the log on with Amazon console, and you can see what I've essentially established is I've got my sample application. I gave it a little bit of metadata around name and description, privacy notice, and then what log on with Amazon gives me back are these client ID and client secret, right? And that's what I've got to go and configure on the other side. So if I flip back into Cognito and I go back up to my user pool, to essentially enable this social identity provider, I need to go back in here. I did already configure it, but just to give you a sense of what it looks like, right? If I'd popped open that, what I really need to do is layer in that client ID and client secret that come from the login with Amazon page. So we're going to if we look at how the attribute mapping works, the nice thing about using these pre-configured social identity providers, you can see here the Cognito today supports Facebook, Google, and Amazon, is that all that attribute mapping that I did before kind of manually with the SAML side of things is already taken care of for me here. So with that in place, really all I need to do is come back. I need to go to that same client application I had before, if I can find it properly. Enable log on with Amazon. Save my changes. Come back here. Get a new browser window. Go to my test. If I sign in now, I should have a third option that's essentially now. So I've now got all three options available to me. It's obviously a little bit fictitious for demonstration purposes, but here I'll log on with Amazon. Hopefully I get the password right. And now I've essentially authenticated to the same single page application, this time using a social identity. Cognito did the same thing as it did before. It took that social identity in this case and converted it into a user pool set of Cognito tokens. You can see the trace back to the original identity is still certainly there, but these tokens that I'm kind of displaying here on the page that are just part of the sample app are actually the Cognito tokens, where Cognito's kind of normalized that. And again, same ritual as before. I use that Cognito token to essentially invoke that Chalice or created API that I had from before. And here again, you can see that I've carried essentially the notion of the user's identity, their email, etc., all the way back into my API. And you know, I hope that it's apparent, but really what the power that Cognito is bringing here is whether I logged in with a user pool username and password, whether I logged in with a SAML federated identity or an OpenID Connect federated identity. By the time it got into Cognito and by the time it got back to the backend API, it had all been normalized to a Cognito user pool set of tokens in a consistent way that I was able to call to execute and authorize the backend API. Super powerful pattern. Okay, now so switching gears, if I want to look at the other use case that I talked about, where we might have a piece of automation that's half in let's see if I can find it. So half in AWS and half perhaps just on-prem in this case. We can use what's known as the client credentials flow out of technically, that would probably be OAuth rather than OpenID Connect, but it's rather indifferent. But essentially what I'm going to do here, and I'll show you how this executes in a second, but I put that set of client ID and client credentials up into Systems Manager within Parameter Store, which is a super powerful, if you haven't used it before, it's a great place to store secrets in a way that gets them out of your code. But I'm going to go ahead and fetch those secrets and then essentially use that as my authentication mechanism to, with Cognito, generate an access token that I could use to execute a custom AMI. I got myself a little bit out of order. Before I go and start executing those things, let's go back first. And I need to, in this sort of case, I need to tell Cognito what the resource server that I'm going to want to generate tokens for. Right now I don't have any, so let's add a new one. I go to my cut and paste help here. Again, we'll pick a simple name. Totally fake identifier. And this is essentially where you'd put in the description of the remote API that you wanted Cognito to vouch for you for, and we're going to put in the notion of a custom scope. A scope is essentially a packaging of attributes in OpenID Connect parlance. So essentially what I've done there is I've told Cognito, you are allowed to issue access tokens for this remote resource server that I've just told you about. Okay, so with that in hand, so again, I'm going to use Systems Manager to fetch the client ID and client secret from within SSM, and then I'm essentially going to just generate here I'm using Python requests to essentially use that client ID and client secret against the token endpoint of Cognito to hopefully generate an access token that it's going to spit out for me. So it's not a terribly interesting demo. Okay, there we go. We got our first failure of the day. Perhaps that was a little too fast. Perhaps I didn't hit go. Let's give it a second. See, I knew I had to. Nobody knocked on wood. That was my problem Okay. Okay. Demo failure of the day. So unfortunately, we're gonna. But had my the demo guy's been with me, and I don't know what I kind of missed there, but we'll move on in the interest of time. But you would have certainly seen a Cognito access token come back, and again, what you'd be able to do there is present that access token back up to your remote API in a way that OIDC becomes your kind of common language that those two could talk. All right, so the first review that we kind of saw here, right, is just, it looks much like it did before. The main difference here is that in the middle line, we've swapped out, instead of our SAML provider, we've got OpenID Connect. Same thing, uses that to authenticate and authorize through that OP, get a set of tokens, use Cognito as that normalizing layer to get a set of user pool tokens, and then ultimately pass those through to Chalice. And then in my demo that I'm still probably going to hate myself for, the simple thing that I forgot later on today, but it's just the life of the demo, I suppose. We used Cognito in conjunction with Systems Manager Parameter Store to fetch the client ID and secret that were related to that application from SSM, so they weren't embedded in our code. And then we used Cognito to generate an access token that we could then present to an external API. Okay, now if you want to go see details and demonstrations, perhaps some that will actually work reliably for Cognito, this Thursday you've got a deep dive here in MGM Level 3. Okay, so let's move on to our next bridge. And this is admittedly stretching probably the traditional definition of federation here, but we're going to consider AD Trust with Kerberos to be our next bridge into AWS. In this world, we've got our on-prem domain controller. Most folks are going to be using Active Directory. And we're going to use AWS Directory Service for Microsoft AD as a bridge. We're going to pre-establish in that mechanism of trust. In this case, our trust is going to come in the form of an AD Forest trust. This is a standard Microsoft technology that's been in play for years. And we're going to use that trust to essentially take Kerberos-enabled resources and domain join them through AWS Managed Microsoft AD back through to your backend or your on-prem domain controller. Now, the reason I would say this fits within my definition of federation is the user credentials are still strictly only in the on-premise Active Directory. We create some authorization-based groups in Managed AD in AWS. We join those on-prem users into those groups, and when we do so, we're able to do OS-level authentication, authorization, or other forms of access, depending on the use case, into AWS, right? And so in this sense, we've pre-established trust, we've not synchronized any identities, and we're able to use the on-prem identities up in the AWS world. So where does this fit in? All right, so we're going to, again, here, that AD trust, we need to pre-establish it in the form of that forest trust. Once we do, the first use case that's going to unlock for us is going to be about Windows authentication and authorization within EC2, and then RDS flavors SQL Server flavors of RDS, right? So again, using those on-prem identities into those AWS services for authentication and authorization. Beyond that, you've also got the Workstar family of AWS applications. The flow is going to be perhaps a little bit different, but it uses that same, you configure that bridge once and you're able to use those identities funneling through that plane of access for those other use cases as well. It's worth noting that you can actually establish federated access into the management console through this AD Trust Bridge as well. In today's world, it has a few limitations. Normally, when in a scenario like this, if you've got SAML as a mechanism to do that, it's probably more mature and more scalable in terms of the implementation you get out of it. But certainly the AD Trust Bridge would be able to provide that as well. Okay, so in the spirit of time, if you want to look at if you want to dive deep into that particular use case, there's an entire Windows track, and I think you'd probably do better off getting some of those sessions instead. And there's a couple that I think would be particularly relevant to you. But it's at least covered at a high level, right? So how does this look for Windows on EC2, right? So we've got much of the same drawing as we saw before. We're going to pre-establish our AD Forest trust between the managed AD and the on-prem domain controller. We're going to domain join through bootstrapping or other mechanisms, those Windows EC2 instances to it. And then after that's established, you're able to just simply create groups within managed AD and AWS. add your on-prem users to that group, and then do authentication and group-based authorization into those instances. This gets you out of the world of EC2 key pairs and other types of things, and just lets you authenticate to your Windows instances in AWS just as you would Windows instances anywhere else. The other use case that, to kind of quickly cover it, the one that I've highlighted here is around workspaces. Here the flow is a little bit different. It's using the same basic trust mechanism, but here the administrator is going to use that trust mechanism to search and provision the backend directory for the users that he or she wants to provision workspaces for. And then at runtime, the user will authenticate with their corporate credentials up into workspaces directly using that same federation bridge. Okay. So let's move on, and the next bridge we're going to talk about is cross-account trust. Right? And again, here I'm being liberal with my definition of federation, but stick with me, and I think it'll make sense. So cross-account trust primer, right? So here we've got two different AWS accounts. One is the source, one is the target. In the target, we're going to establish again another one of those IAM roles that you saw me configure before. This is going to have two components to it. The kind of role creation wizard takes care of a lot of this for you. But the first policy that's got attached to it is the permissions policy, right? And this is, again, where I'm going to establish this fine-grained permissions for what the federated user is able to do within AWS. And then in this case, or in all cases, I should say, we're going to also specify a trust policy, right? And the trust policy for SAML or OpenID Connect said you should trust these identity providers. Here, the trust policy is going to specify the principles in the remote role that are able to assume this particular, it's going to define the roles or the source credentials in the source AWS account that are able to assume into this role. And in cases where we're talking about federation, we always want to use an external ID, and I'll talk about that more in a second. In the source account, we've got either a long-lived or a short-lived AWS source credential. And here, the permission policy is essentially going to say that this AWS principal is able to assume the role in that remote account. So that's kind of the trust, right? The trust policy on one side, the permission policy on the other. So with that all in place, the actual protocol is going to be an STS assume role call. And the target account is going to issue the source account back a set of short-term credentials. So these credentials are bound to that IAM role in the target account and are going to be presented back to the API or CLI caller on the right. Once that principal in the source account has those credentials, it can then use that set of short-term credentials to call any AWS APIs, whether that be control plane or data plane. All right? Now, cross-account trust access is used for a lot of different scenarios. The way it fits kind of into the topic of federation is when you're looking at those two sides of the equation being owned or at least operated or managed by different entities, perhaps you or somebody external, or vice versa, right? And whether that's an ISV, a managed service provider, it really just trying to call out that that is where the two halves of the equation would be owned by different parties. Certainly, cross-account trust support lots of other use cases as well. So don't think this is it, right? But okay, so with that in hand, where does this fit into our picture that we've been building up here, right? So we've got, again, here we're talking mainly about external, in the world of federation, external users, be they users, applications, automation, et cetera. We're going to use their own source credentials. We're going to use the trust and permission policies as our trust bridge into AWS. And then once we've established that, the most notable use cases are down into the control plane and the data plane APIs of AWS itself. Okay. If in terms of how this looks in practice, right? This is a command line version of an assume role call that's going between different accounts. You can see that I've essentially specified the role ARN of the role I want to assume. I've used a role session name just like we saw in SAML. And then here I've added an additional parameter called external ID, right? And in federated cases where you've got different parties on either side of the equation, you want to make sure you use an external ID as kind of as a shared secret to make sure you avoid any sort of confused deputy type scenarios or anything of that nature. Once that's all been done and all the trust policy checks out, the result of the call is, again, you get back that set of credentials in the form of a secret key, an access key, a secret key, and the two additional parts of the short-term credential, which are the session token and the expiration. Okay. Last case, or last bridge that we want to walk through is a custom federation broker. So in a custom federation broker, probably the biggest hamstring of the approach is you have to build the broker, right? So this is a piece of software that you're going to build and maintain in your own environment. While that's a drawback in some ways, what that allows you to do is the world is your oyster, right? Any sort of entitlements or policies or anything that you want to create around sophisticated authentication, authorization schemes, you can define any sort of credentials that you want to require, and you can really implement some really complex patterns here. So the user or the machine is going to present the credentials that you've required. The broker is going to use its own internal logic to figure out what sort of authorizations that credential is entitled for. And then it's going to use either STS assume role or get federated token using its own AWS long-term credentials as the trust, as the proof of identity. And then it's going to issue, in conjunction with what's known as a scoping policy, right? And that scoping policy is going to say that you don't want STS to return a set of short-term credentials that are reflective of the broker's permissions. You want to have STS return essentially the intersection between the broker's credentials and that scoping policy. Once that's done, STS is going to essentially return that short-term credential back through the broker, back through the user, and then they've got the same sort of short-term credential that they can use for any sort of AWS APIs. I will note that this is mostly a legacy mechanism in this case. This was essentially the original form of identity federation into AWS. But these days, with SAML, with OpenID Connect, and others, unless you're doing something really sophisticated around authentication authorization, this is probably not for you. So it fits in much the way the cross-account trust would, right? So here we've got our on-prem identities, we've built our custom broker, we've mandated that they use whatever sort of source credential we've deemed appropriate. We're going to build that trust, again, comes from the combination of we've issued the broker itself a set of long-term AWS credentials that it's going to use as the trust mechanism. And then once we've got that trust in place, we most often see this custom federation broker paradigm being used for either the same sort of console access or federation into the data plane APIs. Okay, so let's wrap it up. So in summary, we've got 5 different bridges of federated identities into AWS: SAML, OpenID Connect, AD Trust, cross-account trust, and custom federation brokers. And we use those many different bridges for different planes of access. Again, keeping in mind whether we're talking about something that's using a VPC level connection, an AWS API. We've got things that talk different protocols, right? So OpenID Connect, SAML, Kerberos, et cetera. And we've got different types of source credentials. Sometimes they're social identities, sometimes they're corporate credentials. We have these different bridges to account for those different cases. We use that to essentially put together that mental model, right? So start with the use cases. What are you trying to solve identity federation for? Flow that through the evaluation stage where we're looking at those 3 principal dimensions above. That's going to naturally lead you to one of the federation bridges that we've talked about here today. And hopefully through the embedded links and some of the things we've showed you, you've got some good blueprints for how to wire in those identities. So now there certainly is some remaining white space. You've seen AWS come out with more and more federated identity capabilities over time. It certainly is not holistic or complete. So if you've got an interesting federated identity use case that's not covered in kind of what we've showed you here today, I'd love to get your thoughts after the session and talk about where you'd like to see us focus next. In kind of the last another slide of some good helpful links, right? So beyond the QR codes that I've embedded throughout, these are some of the other helpful links for things that I didn't quite fit into the slides that hopefully should give you recipes and patterns for all the sorts of different federated topics that we talked about. Wait for the pictures there. Okay, and with that, thank you. I really appreciate the time, really appreciate the attention. If anybody's got any questions, I'll hang out here as long as I can, and hope you all enjoy reInvent in Vegas. Thank you. Cheers.